We need ways also to display quantitative data. Remember, quantitative variables are variables that take a numerical value, okay, such as how tall are you, how old are you, how many pieces of pizza do you eat, how many text messages a day do you send, and so on. Okay? And one of the common ways to display quantitative variables is through a dot plot. A dot plot is very simple. We stack up the dots, that all the numbers that fit into that value or that answer. So goals scored is the example we're going to use for this dot plot. Okay? These are the number of goals scored by the high school soccer team last season. 5 is the first number I see here, 5. So I put a dot at 5. There's another 5, so I put another dot at 5. The third game we scored 1, so I put a dot at 1. The fourth game we scored 10, so I put a dot at 10. And I continue to do this until I have plotted with dots every single value. To make a dot plot simple, there is no y-axis because the heights of the dots give us the y-axis. The x-axis, just make sure that you spread it out evenly and you number from the smallest to the largest. And then we simply put the dots on top. The one thing you need to make sure is that you're stacking the dots at the same distance away. So if I do this dot and the next one's that high, fine. For the next one though, I couldn't say, oh, I have someone scored 7 and then the next time they scored 7, because the distance here between these two dots is not equal to the distance here. So just make sure that when you stack the dots, you do it at equal distances. Now, when we meet a set of data, the first thing we're going to do always is graph it. Well, how are we going to graph it? That depends. If it's categorical, we're going to make a bar graph. If it's quantitative, we have there's a lot of different options we have if it's quantitative. Easy for me to say that. The first one we've looked at is a dot plot. Okay, so first graph it. Then we need to talk, we're going to say this all year, shape, center, spread. We need to describe the distribution. Well, we're describing it visually by graphing it, but we need to describe it numerically, which is what we're going to get into through the rest of the unit, and we need to be able to describe it using words. Okay. So we need to, right now, we're going to talk about the shape of a distribution. What is its shape? Well, shape, we have 3 choices. It can be symmetrical, it can be skewed left, or it can be skewed right, or it could be any degreeing variations of those. So it could be perfectly symmetrical, it could be strongly left skewed, it could be slightly right skewed. There's lots of different choices. But what we're going to be doing is fitting a curve to the distribution. So here is 3 separate dot plots. The top one here looks really symmetrical, and I write much better with a pen than an eraser. You see how it looks symmetrical? We're going to say that this data is roughly symmetrical. Now, if I tried to fit a curve to the top of all these dots, you would see that this tail is pulled out to the right. This is an example of right skewed. And same for the one down bottom. This is an example of a data set that is left skewed. Okay. So these dot plots will give us shape. Its shape is either symmetric or skewed. Let's take a look at this example. The dot plot display 2 different sets of quantitative data. Graph A shows the scores of 21 stat students on their quiz. So if you look at these scores here, majority of the people scored perfect, 20 out of 20. And then there was a couple chuckleheads that have numbers really low, like 10 or 8. Okay? But the majority of the data is stacked up on the far right. So if you look at this student way out here with a score of 10, he skewed the data towards that side. He pulled the tail out towards him. Therefore, this would be an example of left skewed. The data is extremely skewed to the left. If you look at graph B, which shows the results of the rolls of 6 of a die 100 times. So they took a die, they rolled it 100 times, and they made a dot plot of what number came up. Well, this data is roughly symmetrical. It doesn't appear to be skewed left, skewed right. it looks to be relatively symmetrical, meaning that you can identify a center and it's roughly the same on both sides of that center.